Hello everyone, and welcome to the video on transformations. The transformations are a little bit different than other things just because of the fact that we're going to be looking at these graphically. So some of this is we'll also discuss this in class just because I have access to the graphing calculator and we can make sure that everybody is putting it in the exact same way and we can kind of see all the different transformations there. So we'll start out though just kind of talking a little bit about these different transformations. So to start out with, our skill objectives for this one is we want to be able to sketch the graph of a function using horizontal or vertical shifts. Sketch the graph of a function by reflecting about the x or y axis, and then we're going to be looking at sketching the graph of a function by stretching or compressing. Okay. The stretching, to be honest, the stretching and compressing is one that is a little bit tricky for people to see because of the types of functions we work with. Hopefully when we get to class and I show you a couple other examples of different types of functions, that you'll get a better idea of what it means to stretch or compress. The conceptual objectives for this one are to identify common functions by their graph. In other words, recognizing the base function, what the base function is. Number 2, apply multiple transformations to common functions. And 3, understand domain and range are also going to be transformed whenever you do a transformation. First up, what I'd like you to do is I want you from the last video, we talked about the common functions and some that you should be familiar with. So I want you right now take a look at the list that I have here in terms of y equals x squared, x cubed, the identity function, squaring function, cubing function, and then we have the square root function, the cube root function, the absolute value function, and the inverse function. When you look at those right now, I would hope that you do have at least a basic understanding of what each one of those will look like graphically. If you do not, please pause the video and go to page 175 of your textbook. That is the summary for Chapter 1, Section 2, and it shows you these basic functions, these common functions that we'll be working with. So if you're comfortable with these, then go on. Otherwise, pause the video and make sure you are comfortable with each one of those types of functions. Another thing that we want to make sure that you have in terms of an understanding of points on these graphs is that any point x, y is basically going to tell us a distance. It's a directed distance from each axis. The x-coordinate, remember to get to the x-coordinate, we start at the origin, and the x-coordinate tells me how far to move left or right off of the origin if I'm going to graph. So that's what I mean by directed distance. If x is negative, we move off of the origin, we move to the left. If x is positive, off of the origin, we move to the right. So the x-coordinate really tells us a distance, how far away, either to the left or to the right, our point is from the y-axis. The y-coordinate does the same thing with the x-axis. It's a directed distance. So if the y-coordinate is positive, we move up. If the y-coordinate is negative, we're going to move down. For example, the point 2, 3 that we have right here. The 2 tells me that it's positive, so I know I'm going to be moved 2 units to the right of the y-axis. And the 3, since it's positive, tells me I'm going to move 3 units above the x-axis. Now that's going to be key for the transformations because all the transformations are going to be changing these distances and altering the direction that we go. So you have to keep in mind in terms of the coordinates that not only does the 2, 3, it has a location, but it's also giving you a directed distance. Same thing with -4, -7. The -4 here tells me that we are 4 units to the left of the y-axis. That I had to go 4 units to the left of the y-axis to get to that. And the -7 tells me that I had to go down 7 units below the x-axis. And again, keeping in mind this idea that the point is each coordinate represents a directed distance will really help out with keeping the transformations and the effect of what those transformations have on the graph and the individual points. Keep that fairly clear. So how do transformations change a point? Really what it's important to remember is a vertical transformation will change the y coordinate. It's going to do something to the y coordinate. It will not touch the x coordinate. No vertical transformation will ever change the x coordinate, but it will change the y coordinate. Whatever the transformation is, it might involve multiplying it by a number. It might involve adding or subtracting something. It might involve changing the sign. Those would be what the types of transformations we have to deal with. A horizontal transformation only changes the x coordinate. So a horizontal transformation now is never going to affect the y. So it's going to do the same things. It could do the same things to that x coordinate in terms of it can add or subtract a number from it, it can multiply it by a number, or it can change the sign. I cannot stress enough the fact that no transformation, no single transformation will ever change both the x and y coordinates. Now we could have multiple transformations that are in a problem, one that is a vertical, one that's a horizontal, and that could then change both coordinates. But a single transformation will never change more than one coordinate, either the x or the y. If it's a vertical transformation, it will change the y coordinate. If it's a horizontal transformation, it will only change the x coordinate. What I'd like you to do right now, we're going to look at horizontal and vertical shifts. These are ones that are fairly easy to work with and easy to see. So what I'd like you to do, if you don't have it already, I'd like you to pause the video and get your calculator, or at least borrow one, or take a look, find something where you can go and graph with. So pause the video, get your calculator, then come back, we'll continue on. Okay. What I'd like you to do, we're going to start out just taking a look at these shifts. Now, I've already have a couple graphed on here. You can kind of see what's happening with them, but I'd like you to go and graph them anyway. y1, I want you to let y1 equal x squared. And then for y2, let y2 equal what I have in red here, y equals x squared plus 2. Now, when you graph that, go ahead and graph it. And when you do, you should see something along this. You should see two graphs, one on top of each other. Okay, the graph that I have here in black, the black graph, that is y equals x squared, and the red is y equals x squared plus 2. Now I want you to notice something. In terms of what I have in black, what the effect, we want to talk about the effect of that plus 2. Well, what it did is it took the point here, let's say we are at the origin, the vertex of the x squared is at the origin, it moved it up to the point 0, 2. In other words, we went up 2 units. The point here at 1, 1 went up to the point at 1, 3. Again, up 2 units. And the point here at 2, 4 went up to the point at 2, 6. Again, added 2 units. So in this instance right here, this one, y equals x squared plus 2, this is a vertical shift. This one is a vertical shift. And the plus 2 went up, told me I was going up 2 units. Now, what I'd like you to do is graph, instead of get rid of the x squared plus 2, replace that with y equals what I have in blue over here, where y equals x minus 4, that quantity squared. Make sure the minus 4 is inside those parentheses. You got to have the parentheses there. Y equals the quantity of x minus 4 squared. And when you graph that, when you do graph that, you're going to notice the graph in black again is my graph, if you will, of y equals x squared. And what I have in blue is the graph of y equals the quantity of x minus 4 squared. And you're going to notice on this that I shifted this graph, shifted horizontally. It moved to the right. Okay? My vertex here is at 0, 0. Come over here, the vertex now is at 4, 0. I have one point here at the point 1, 1. This point here is the point 5, 1. This was the point negative 1, 1. When I shift it over 4 units, I get to the point 3, 1. So there's the difference. So in this case, what I have on this one, this is a horizontal shift. Now, the other thing I'd like you to notice, and this is another key part with this, when I talk about horizontal and vertical shifts, I will often talk about something being inside the function, the transformation inside the function or outside the function. What I'd like you to notice right now, in terms of the vertical shift that I have right here, that the +2, I talk about that being outside of the function. I had x squared, and then I had the x squared, and then the +2 came after that. In the horizontal shift, you notice it is inside the function. I talk about that being inside the function. Okay, so if you make sure that you are comfortable with what I mean, why I say one is the vertical shifts are outside, the horizontal shifts are inside, because that is also going to be key. Vertical shifts are always going to be outside the function. They're going to be something that's sitting outside of whatever our base function is. The horizontal shifts are always going to be something that takes place inside the function. Okay, so if you're not comfortable with that terminology outside or inside, make sure to make a note of that right now in your notes, because that is going to be another key aspect in terms of identifying and understanding transformations. Now let's look at a different base function. We'll look at y equals the square root of x. You should have an understanding of what that graph is. If you're not sure, go ahead and let y1 in your calculator be the square root of x. And now, once you have that, what I'd like you to do is pause the video, and I'd like you to graph each one of these functions that I have here into y2. So first time you'll have y2 is the square root of x plus 4. Now what you're going to notice over here, for those of you with the older calculator version, operating system, you will need to go through, when you put the square root in, put the square root of x, and then put a parenthesis to close off the square root there, and then the plus 4 outside. Those of you with the newer operating system, remember that after you put in the x, to use the arrow key to get out from underneath that square root. But what I'd like you to do is graph each of these ones individually, and compare it to the square root of x. So do the square root of x plus 4. Then, once you have an understanding what that does, do the square root of x minus 3. And then the third one, do the square root of x minus 1. And just describe what transformation has taken place. In which direction did I shift, and how far did I shift? Once you've done that, do the same thing with the ones down below in blue. Okay, notice again with the older calculators, you're going to have the square root of the x plus 4, and you have to close it off. In the newer calculators, when you put that in there, just put square root, and after you put in the 4, use the arrow to get out from underneath the square root. So pause the video, go through on your calculators, and determine what has happened with each one of those transformations, and be very specific. Okay. Welcome back. Let's just go through the first ones, if you will. The first one, when you did this, the square root of x, then plus the 4, that is, I want you to recognize that as being outside the function, and that moved it vertically up 4 units. So the graph was just shifted vertically up 4. Every unit, every point was now 4 units further from the x-axis than it was before the transformation. In the second one, it moved everything down 3. So in this case, what I did is I just shifted that graph down 3, and really what ended up happening is I subtracted 3 from all the y coordinates. And finally, in the third one, y equals the square root of x minus 1. That again is outside, that minus 1 is outside the function right now, and that moved it down 1 unit. So again, every point was, what I did is I ended up subtracting 1 from every y coordinate. Now, let's take, if you haven't done so already, take a look at, make sure you're comfortable with what you have with those. And if you have questions on the vertical transformations there, please make sure to note that in your notes and ask that when I see you in class next. Let's go on to the next set, the ones in blue. In terms of the next set, with y2, and I had the square root of x plus 4. Now the plus 4 is inside of that square root function. And when I graphed that, you should have found that it moved to the left 4 units. Okay, might be a little bit surprised on that one, but it did go to the left 4. In the next one, you had the square root of x minus 3. That negative minus 3 is inside the function, and it moved it to the right 3 units. And the third one moved it to the right 1 unit. Now, this also brings up a situation you have with the vertical transformations, the vertical shifts, and the horizontal shifts. In the vertical shifts, when I had the plus 4, like the plus 4, or if I had a positive there, if I was adding something, the graph shifts the direction I expect it to. The vertical shift, it moved up 4 when I had a plus 4. It moved down 3 when I had the minus 3, the square root of x minus 3. The horizontal shifts, for a lot of people, they look at it, they go, wait a second, it kind of went backwards. It went the opposite direction. A lot of people will look at that and they'll say the square root of x plus 4, they're expecting to go one direction. And in reality, it really goes to the left 4 units, kind of the opposite of what people think. In this case, the square root of x minus 3, it did go to the right 3 units. So you need to keep that in mind. Okay, a lot of times, what I tell people, a lot of times with the vertical transformations, they will do what you expect them to do. The horizontal transformations, for a lot of people, when they look at it, they end up doing the opposite of what they expect. So let's kind of summarize our vertical and horizontal shifts. When I have f of x plus c, like I have right here, in that situation, if c is greater than 0, we're going to shift up. And if c is less than 0, we shift down. And again, that makes sense to people. I think usually most people feel like, yes, that does make sense. If I add something, add a positive number to it, I should be moving up because that's up on the y-axis. If I go and add a negative or subtract something from it, I should be moving down. Now, you'll notice with the horizontal shifts that I have it as f of x minus c. Okay, now you got to keep that in mind because in this situation when I had x minus 3, that would mean that c itself is a positive number. Okay, so that's why we end up doing it, because when c is positive, we want to think of it as shifting to the right. So in this case right here, when I had x minus 3, c is a positive number, whereas in the first one, when I had square root of x plus 4, c is going to be in negative because it's going to be x minus, you got to think of it as x minus a negative 4. Okay, so always remember with the horizontal shifts that the sign on c is going to be the opposite of what you see in that problem. So in this case, when c is greater than 0, oops, let's put the pen on. When c is greater than 0, it's going to shift right. And when c is less than 0, it's going to shift left. And in all of these, the shifts are going to be c units. So when it's a vertical shift up here, when c is positive, it's going to go up c units. In this case, it's going to go down c units. This will be to the right c units, and this will be to the left c units. All right, now let's look at reflections. Our base function in this case is going to be y equals f of x. And the first thing I want you to notice in this one is I have the negative sign is outside of that f of x. So it's negative f of x, or the opposite of f of x technically. And when you see that, that will always be a reflection over the x-axis. Okay? And when I think of that, when I reflect something over the x-axis, so in other words, I'm up here, and when I reflect it over the x-axis, I'll be down here. Or I might be down here, and when I reflect over the x-axis, I'll be up here. I look at that as a vertical transformation. I'm going from high to low, or low to a high point. It's just reflecting vertically, okay? And in that instance, that's why when I look at that, I think of that negative sign there as being outside the function, so that it would be a vertical transformation. In this case, down here in blue, you have f of negative x, or the opposite of x. And in that situation, what we're doing is we're going to be reflecting over the y-axis. So it's going to start on the right, go to the left, or be on the left, and reflect over on the right. But you will always reflect over the y-axis. Now, when you do a reflection, when I do a reflection, because if I reflect over the x-axis, since it is a vertical reflection, it's a vertical change, I realize that that is going to just change the y-coordinate. And really what it's going to do is it's going to change the sign on the y-coordinates. If the y-coordinates are positive, it's going to make it negative. If the y-coordinate is negative, it's going to make it positive. In the horizontal reflection, or the reflection over the y-axis, because I'm switching it, moving it left and right, that is just going to change the sign on the x-coordinate. If the x-coordinate is positive, it's going to make it negative. If the x-coordinate is negative, it will make it positive. So really keep that in mind. Vertical transformation, it changes the y-coordinate, so a vertical reflection is going to change the sign on the y-coordinate. In a horizontal transformation, it changes the x-coordinate, so a horizontal reflection is going to change the sign on the x-coordinate. Let's take a look at how these transformations affect the graph, and we're just going to be looking at shifts and reflections here. Okay, so I have a function f of x, and it has the points, it contains the points -3, -1, -1, 2, 2, 2, and the point 3, 0. And let me close that parenthesis there. Okay, now what we're going to do here is I'm going to look at the graph. I want to go and graph three transformations on that. The first one I'm going to graph, I'm going to look at f of x plus 2. Notice the plus 2 is on the inside, and then a minus 3 on the outside. So the plus 2 on the inside tells me that this is going to be a horizontal transformation. And because in this case, remembering C always has the opposite sign that you see in here, I know that C is a negative number, so I'm going to move all these points, every point to the left 2 units. And then the minus 3 tells me I'm going to move down. So let's start out with the point at -3, -1. When I go through, I'm going to move it to the left 2 units. So if I start out at -3, -1, so I'm right there, I'm going to move it to the left 2 units. I should put another mark there. So I'm going to move it, I will move it to the left 2 units, so 1, 2. And I'm going to go down 3 units. So I'm going to go down over here to 4. So I'm going to be at -5, -4. So I'm going to go and put a dot at -5, -4. That's where the point 3, 1, was switched to that point, which is at the -5, -4. The next point I have is -1, 2. Well, -1, 2 is right there with the transformation that the first one is the plus 2 is going to be to the left 2 units. So I'm going to move it to the left 2 units. So I'll be here. And then I'm going to go down 3 units. So when I shift it down 3 units, I'm going to be at the point -3, -1. And so I'll put a dot at the point -3, -1. Now I have the point 2, 2. And so I'm going to start at 2, 2. I'm going to move it to the left 2 units, and then I'm going to go down 3 units. So that's going to put me at the point 0, -1. And finally, I take the point 3, 0. I'm going to go to the left 2 units, and I'm going to go down 3. And it's going to put me at the point 1, -3. And so graphically, after I apply the transformations, that's basically what I'm going to get. So what I'd like you to do right now on this next one, which is f of the opposite of x plus 1, I want you to go through, identify the transformation on it, and then try applying that transformation just to the point -3, -1. Recognize what type of transformation it is and apply it to that point. And once you've done that, once you have that, come back and we'll go through this one as well. Okay, welcome back on this one. In this case, in this problem, the minus sign inside there, the f of the opposite of x, tells me this is going to be a reflection over the x or the y-axis. So I know I'm going to multiply, I'm going to change the sign of my x-coordinate. The plus 1 tells me it's going to be shifting up 1, so it's a vertical shift up 1, so I'm going to have to add 1 to the y-coordinate. So in this case, when I had the point -3, -1, the reflection over the y-axis tells me I'm going to go to a +3, -1, and then when I move it up 1, I am now going to be at the point 3, 0. So it's starting out right here at -3, -1. I shift it, reflect it over the y-axis to +3, 1, and then up, and I'll be at the point 3, 0. So that's going to be this point right there. Now, go through, apply the transformations to each one of the remaining 3 points, and give us a sketch of that graph, and come back and we'll take a look at how you did. I've now graphed that each point on there, and I've labeled them. So what you should have had happen is that the point at -1, 2 would end up going to the point at 1, 3. That would flip over the y-axis and then move up 1, change the sign on the x-coordinate, add 1 to the y-coordinate, and that's where you should end up. The point at 2, 2 would be transformed to the point -2, 3, and the point at 3, 0 would go to -3, 1. Now, in this next one, I'd like you to identify those transformations and again apply them to this graph. So in this case, the negative sign tells me it's going to be a reflection over the x-axis. So I'm going to change all the signs on the y-coordinates. And the -2 tells me it's a horizontal shift to the right 2 units. So I add 2 to the x-coordinates. So go ahead, make those transformations and draw the graph and come back. Once you're done, come back and take a look at how I did compared to how you did. Welcome back. When you did that transformation, when I reflect it over the x-axis and shift it to the right 2, I know I have that the point -3, -1 became -1, +1. That's when I reflecting over the x and shifting it to the right 2. Then I had the point 1, -2, 4, -2, and 5, 0. If you have any questions on how I got each one of these points, please mark it and make sure to ask about it next time we're in class. This does conclude the portion of the video that we need for the next class. So if you would like to stop now, you can, and we can or you can go on. It shouldn't be much longer to finish up this because a lot of the stuff with the compressions will take place in class. Let's take a look at let's give you just a summary of stretch versus compression. Okay, and when we talk about stretch and compression, what we're going to be doing here is we're going to be either stretching vertically or horizontally, or compressing the function vertically or horizontally. Now, often the functions that we deal with in this class and what we're dealing with right now, it really makes it hard to identify the difference between a vertical stretch or compression and a horizontal stretch or compression. So just keep in mind that a lot of the problems that we deal with right now, you might not necessarily notice too much of a difference between them. But in class, I'm going to show you a couple examples to kind of really illustrate how the vertical stretch is different from that horizontal stretch and shrink or compression. When we're dealing with a base function y equals f of x, if you see where y equals some constant times f of x, that is going to indicate a vertical stretch or compression. Again, notice the c is outside the function, so I would expect it to be a some sort of vertical transformation. And the effect that's going to have is that's going to go, and that means I'm going to be multiplying the y-coordinate by whatever c happens to be. Okay? Now, when c is greater than 1, it is a vertical stretch, and when c is between 0 and 1, it is a compression. In other words, when I multiply by something bigger than 1, I'm going to be stretching it out. And again, I think for a lot of people that makes sense. When I'm dealing with, when I multiply by something between 0 and 1, like a fraction like 1/2, that is going to be a compression. It's going to make it shorter. Okay, so that's the vertical stretch and compression. Now, with the horizontal stretch or compression, that c is now inside. Okay, when when C is between 0 and 1, it is going to be a horizontal stretch. Now again, this kind of stays in line with what we talked about before, where vertical transformations seem to do what you expect. Horizontal transformations actually end up doing the opposite. So a lot of people, when they think of it as C being something between 0 and 1, they're surprised when they hear that's going to be a stretch. And what I'm going to do is I'm going to divide. In this case, when it's a horizontal stretch, I'm going to divide the x coordinate by whatever C is. And then when C is greater than 1, that is going to be a horizontal compression. And again, I'm just going to divide the x coordinate by whatever value I have for C. So that's kind of a summary of those. And again, to really get an understanding, I can give you some basic functions that you're familiar with graphing them. But to really get an understanding of them, I really need to show you using a couple of different types of functions so you can kind of really see that change, how those change. So we'll look at some of those in class next time. Additionally, when we're in class, we will talk about how to deal with the multiple, when you have multiple transformations. But let me just leave you with this little bit with that. In general, order of operations kind of helps out. Okay, you go through, you know order of operations, you do what's inside parentheses first, multiplication, division, then addition, subtraction. You apply transformations in the same way. Apply the inside stuff first when it's there, go through, multiply, divide first, second, and then the addition, subtraction after that. This does conclude our video on the transformations. Again, make sure that if you have any questions about them from this, I know this is it's not going to answer every question right now in this video. We will take some looking at some of the examples I can do in class, but that's where we'll focus that time. But make sure you write down any questions that you have so that they do get answered when you come to class.